This is the lesson for Chapter 3, Section 4, and it's Part 2. It's basically operations with scientific notation, but dealing with some word problems. So we've got each of the operations that we're going to end up having to use in this lesson. So let's take a look at our first problem. So it says a newborn baby has about 26 million cells, or 26 billion cells. We got three sets of zeros here. We got 3 here, 3 here, and then 3 here, so we're at 26 billion cells. An adult has about 1.9 times 10 to the third times as many cells. So right there, that word times as many tells us right away I'm going to end up multiplying. So what we're going to end up doing is doing this. So our problem is I'm going to change this to scientific notation. So I'm going to write that as 2.6, and then I've got to count the spaces I need to move the decimal. So it's easy to count them, especially when they have the comma. So I have to move it 1 plus 3 sets, 3 sets, and 3 sets make 9. So that makes 10 altogether. So 2.6 times 10 to the 10th power. And I'm going to multiply that by 1.9 times 10 to the third power. So when I multiply in scientific notation, remember you're multiplying the two numbers, 2.6 times by, and then 1.9. And then once I do that, I'm going to also multiply the numbers with exponents. And I can add up those exponents and count how many we have. So when I go ahead and multiply these two numbers, I end up with 4.94. And this is 10 to the, and then I have to add up the exponents. Remember, that's the rule with exponents. You add up those exponents. And so we end up with 4.94 times 10 to the 13th power. So what we're going to do is read the question and kind of restate the question as our answer. About how many cells does the adult have? So we can say an adult has about, and then we can state the number, 4.94 times 10 to the 13th cells. So looking at the next one, it says that the diameter of Andromeda galaxy is approximately 2.2 times 10 to the 5th light years. This equates to 1.298 times 10 to the 18th miles. So sometimes people get so confused reading the numbers, so don't worry about the numbers so much. Let's take a look at what they're looking for. And right here's the question. Find the approximate number of miles in 1 light year. This gives it away right here, in 1. So I could rewrite this another way. They could have said miles per light year, because per light year means just 1 light year. And so when we see that word per, that means we're going to end up dividing. And so another way to write that would be this: miles over light years. And so now what I'm going to do is set up my problem as this fraction. So miles is going to go on top. So I'm trying to see how many times the number of light years goes into the number of miles. And so you see how we have that number on top, the miles on top, the 2.2 times 10 to the 5th. That's the number of light years. That's going to end up going on the bottom of the fraction. And so then we're going to end up being ready to do some division. So I'm going to set up the division this way. I've got 2.2 into, and then the 1.298. And so remember, the decimal point is going to move over, and decimal point goes up, and it ends up being 0.59. And so what we've got is 0.59 times 10, then we have to subtract the exponents, so 18 minus 5, because we've got the division there. So we'll rewrite it as 0.59 times 10 to the 13th power. But that's not in proper scientific notation. So what I have to do is move that decimal point over. So I'm going to move that decimal point over one space this way, so it becomes now 5.9 times 10. Now, since I moved this one, made this one bigger, that means I need to make this one smaller to keep it in balance. And so that's going to end up being 5.9 times 10 to the 12th. And so let's go ahead and restate the question there. So find the approximate number of miles in 1 light year. So we could say there are 5.9 times 10 to the 12th miles in 1 light year. And so there's that one. Let's move on to the next one. So this one asks us to, says the population of China is this amount, and the population of Australia is this amount. So don't get tied up trying to read off the numbers. Just kind of flow through this reading here. And let's get to the question, because that's the big thing. What is the combined population of China and Australia? Combined means sum. Sum means add. And so that's what we're going to end up doing. So I have to add 1.33 times 10 to the 9th, and I'm adding that to the 2.15 times 10 to the 7th. But our problem is that the exponents are not the same, so I need to make them the same. So let's go ahead and move that decimal and make this number smaller so I can make the 7 bigger. So we're going to move that over 2 spaces. So that number is going to become 0.0215. So I moved it over 2 spaces, so that way I've got a 9 as the exponent. And so I'm going to add on this other number to make sure that I line up the decimals. And since I'm adding, I don't need to worry about having the numbers lined up. I don't need to worry about having the bigger number on top. And so from this point, I need to go ahead and add those numbers together. So I go ahead and add these numbers up, and I end up with a 1.3515 times 10 to the 9th power. So now we just need to state that question again, rephrase that to explain the answer. So we would say the combined population of China and Australia is, and then I'm going to write down 1.3515 times 10 to the 9th power. And so that would be the third problem. Let's take a look at our last problem here. So it says the total area of the 50 U.S. states and Washington, D.C. is, and then they give us the number in square miles. And so this is a total. And of that, this amount of square miles are water. And so the rest of the area is going to be land. So how many square miles are land? So what we have here is a total, and that equals the amount of water, H2O, plus the amount of land. So the land plus the water is going to give us the total area. So what I need to find is the land, because I have the water. So if I wanted to find out what the land is, I need to subtract the amount of water from the total. And so doing it like this makes it so I don't have to worry about rewriting these numbers, these large numbers. And it just kind of gives me an idea about what I am trying to do in order to come up with the answer. And I need to subtract. I need to subtract the amount of water from the total. So let's set that up. So I've got 3.79 times 10 to the 6th. I need to subtract this number here, the 2.57 times 10 to the 5th. So what I need to do is make these exponents the same. So that means I need to move this decimal over 1 space. That means that will make this a 6. So let me rewrite what I've got. So it's going to be 3.79 times 10 to the 6th. And now I've got 0.257, and that is times 10 to the 6th now. So I'll add the 0 right above the 7, and I'll do the subtraction. So now remember, you have to borrow. And if you don't add that 0, sometimes you won't see that borrowing. So I borrow, and then I end up with 3.533. And that is times by 10 to the 6th power. So that's the answer. Let's go ahead and rewrite the answer from the question. And what we could say are, there are, and we can write down how many square miles we have. 3.533 times by 10 to the 6th power square miles of land in the United States of America. And so there is our answer. So those are the types of problems that you're going to see on tonight's homework. Good luck.